Okay, this is the third time trying this. I hope this is going to work. If not, I'm probably going to give up. But what we are looking then is finding the quadratic nth term of sequences, or rather the nth term, I should say, of quadratic sequences. Well, when we think about nth term, when we're thinking about sequences, our first instinct is always to find the difference. And in this case, just the same, we're going to find our difference. So what we are going up by. So from 7 to 11, I'm going up by 4. From 11 to 17, I'm going up by 6. From 17 to 25, I'm going up by 8. From 25 to 35, I am going up by 10. Nice. Now, normally on the linear nth term sequence, this would all be the same. This would be a value of n. It's not the same. So what we are going to do for a quadratic nth term is find the secondary difference by finding the differences of our difference. So from 4 to get to 6, I'm adding 2. From 6 to get to 8, I'm adding 2. From 8 to get to 10, I'm adding 2. Boom. So we have got 2, 2, and 2. Our secondary differences are the same. Now, this is a key step. We take our secondary difference, which is 2, and we half it. We divide it by 2 every single time. Whatever our secondary difference is, we are going to divide it by 2. In this case, 2 divided by 2 equals 1. Now, this 1 is important because it is our coefficient of n squared. Coefficient of n squared. In other words, I'm going to write, I do not want you to solve that, thank you so much, of n squared. So 1 means I've got 1 n squared, just like that. Okay? Then, if we think about what a quadratic nth term looks like, right? Now, this part is going to sort of explain the maths. Feel free to skip forward 30 seconds or so if you don't want it. Or if you get confused, that's okay. I'll show you the steps in a second, but I will explain why we're doing what we're doing. Well, we know that our quadratic nth term is going to look something like this. It's going to look like something n squared, let's say an squared, plus something n, let's say bn, plus something c. Well, I have just worked out that my a is 1, right? I've just worked out that my coefficient of n squared is 1n squared. So I know what a is, but I need to work out bn plus c. Well, bn plus c, this section here, looks to me like a linear sequence. So what I want to do is cancel out this an squared. And the way we do that is like this over here. Okay, if you're ignoring that mathematical explanation, now you're locking back in because I'm going to explain the next step. The next step is to write out your sequence again. So I'm going to write out 7, I'm going to write out 11, 17, 25, and 35. Oh, let's ignore the email pop-up. Okay, nice. 7, 11, 17, 25, and 35. Nice, nice, and nice. And what I'm going to do is underneath write my sequence of 1n squared. I need to write out this sequence underneath so I can subtract, so I can cancel out. So I'm going to write out my 1n squared sequence. Well, remember when we're finding sequences from the nth term, we're just inputting, we're substituting in 1, then 2, then 3, then 4, then 5. So remember we're doing 1 times n squared. So n squared is 1 times 1 is 1. 2 squared is 4 times 1 is obviously 4. 3 squared is 9. Times 1 is obviously still 9. 4 squared is 16. Times 1 is 16. And 5 squared is 25. Times 1 is 25. And I am going to subtract. So 7 take away 1 gives me 6. 11 take away 4 gives me 7. 17 take away 9 gives me 8. 25 take away 16 gives me 9. 35 take 25 gives me 10. Now I have got my linear nth term, which I can now calculate using the method I always know how to do. So am I different? I'm going up by 1. 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 Fantastic. So then I've got 1n, which means I'm in a version of the 1 times table. But what am I shifting up by? Well, 1 times table starts on 1. My sequence starts on 6. So it's going to be 1n plus 5. So my final steps is bringing it all together. So I have got 1n squared plus 1n plus 5. If I was a foolish idiot child, I would leave it like that. Obviously, we know in algebra, when I've got 1n squared, I don't need that one. That's just n squared plus n plus 5. Beautiful. Okay? That is how we do the quadratic nth term. To recap, there are sort of 5, 6 important steps, which I'm going to go over here and write. Step 1, find the secondary difference. Yeah, so I found the differences, and then I find the differences of those differences. So find the secondary difference. Step 2, divide this by 2. Okay? Oh, divide this by 2. And this is the value of your n squared. If it's 4 divided by 2 is 2, 2n squared. 10 divided by 2 is 5, 5n squared. This is the value of n squared. Nice. Step 3, subtract the sequence of an squared. In this case, the question before it was 1n squared, from your sequence. So I laid out my sequence, didn't I? I wrote it all out. Underneath, I wrote my n squared sequence. I subtracted. Step 4, find the nth term of your resultant linear sequence. Of the resultant sequence, I'll write. And step 5, put it all together. Okay? What we're going to do now, what I'm going to do is I'm going to go to this next question. You are more than welcome to pause the video, give it a try, look at your notes, look at the steps, look at my example before, give it a try, but I'm going to go through it in 3, 2, and 1. So step 1, finding my difference. So from 10 to 20, I've added 10. From 20 to 34, I've added 14. From 34 to 52, I've added 18. From 52 to 74, I've added 22. They're not the same. No, they're not, because it's not a linear sequence. It is a quadratic sequence. So now I'm going to go find the secondary difference. From 10 to 14 is 4. From 14 to 18 is 4. From 18 to 22 is 4. So boom, I've got 4, 4, 4. My secondary difference is 4. What do? I half it. I divide by 2. 4 divided by 2 gives me 2. So 2 is my coefficient of n squared. I have got 2n squared. Boom. Then underneath or next to it, I'm going to write out my sequence again. 10, 20, 34, 52, 74. And underneath, I'm going to write my sequence of 2n squared. Remember, 2n squared does not mean times it by 2 and then square it. Think about our BIDMath. This means 2 multiplied by n squared. So for your 1, 1 squared is 1 times 2 gives me 2. For 2, 2 squared is 4 times 2 gives me 8. For 3, 3 squared is 9 times 2 gives me 18. For 4, 4 squared is 16 times 2 gives me 32. For 5, 5 squared is 25 times 2 is 50. And I subtract. What do I get? Well, 10 take away 2 gives me 8. 20 take away 8 gives me 12. 34 take away 18 gives me 16. Is that right? I believe it is. 52 take away 32 gives me 20. 74 take away 50 gives me 24. And there we have my resultant linear sequence, which I am now going to find the nth term of this sequence here. So let's do it. Well, what am I going up by? I'm going up by 4. 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 So then it must be 4n, but that means I'm in a version of the 4 times table. My sequence starts on 8, so I've shifted up by 4, because of the 8 here. 4n plus 4. So my final step is that I'm going to bring everything together. So my answer is 2n squared plus 4n plus 4. Life is good, life is sweet. I get my 4 marks, and I move on.